Lindsay. I'm Systems Design Engineer with Extron Electronics. For those of you that haven't stopped by our booth, if you have a few minutes after this, please stop by. Thanks for attending LiveCon. So your host back here, great today. So I want to talk about streaming and recording in the installed commercial environment and some things to consider. So some of this has got a little bit to do with our product, but at Extron, we also believe in education for the general application. So as I go through this, you're going to see some things that's got our product in it, a couple things I'll talk about on our product, but the wealth of this is just general industry knowledge. On the agenda today, and sorry I'm running dual mode here and I already messed up the first slide. So on this, I want to talk about an introduction and a history. So kind of where we come from with streaming. Streaming is a very loose term, and it's been around actually, as I'm going to show you, since the early 90s. We're going to talk about streaming over IP networks, because that's most of what everybody in the room today wants to do, but there's multiple ways to do streaming. So I want to focus on that. Recording. You want to record the session while you're streaming it. You want to record it instead of streaming. All of those things come in, and there's different things to take into account on those. The streaming topologies we have. So we have types of different topologies. We're talking about IP primarily. There's other communication streaming that I'm going to talk about as we go through with those. Encoder configuration settings. So as we talk about that, the encoder is the device that's going to actually do that compression, whether it goes out on the internet or whether it goes out through satellite transmission, as an example. Anything that we do that converts video from full bandwidth to a partial bandwidth and involves compression, and that's all set up in an encoder. Unicast, multicast. In small, simple terms, one-to-one or one-to-many. And there's advantages and times that you want to take up and look at both of those as we look at that. And then we're going to talk about an overall streaming system design consideration. When I talk about that, that's going to have a few bullets that if you don't take notes on anything I talk about today, take notes on that slide, because that's going to be your go-away point that you're going to consider everything onto your streaming platform. And then streaming designs and Extron solutions. Obviously, I want to talk about some of those a little bit. And then, as I've got my timer up here, as long as I don't go over time, we can do a small question and answer and talk about a couple things. Keep going with that. So as we go down this, we want to talk about the streaming and recording applications. So we've got different types of events, just like today, presentation and streaming meeting. I started to say if this, I know this is being streamed and recorded. So this is an example of I want to be able to stream this out into another room and record it for future use. Corporate training systems, they do recording a lot of times more than streaming. So that's where we kind of want to mix and match what the product goes through. I might be sitting up here talking about safety, talking about new employee training, anything of this such, and that's going to be recorded. Rehearsal systems. Common with presenters, especially presenters that are getting paid. So I want to stand up here and rehearse my presentation. I want to rehearse what I'm going to talk about, and I'm going to get a peer review or maybe a management review. So all of those things are types that we would use them for. Meeting and conference rooms. You guys have all sat in meeting rooms anymore, and everything needs to be documented. It needs to be documented both just for safety and so that what we talked about is there. And then the lecture capture, which is the typical training room, whether it be an education or a higher education thing. So those are just kind of some of the things that we have at that. And so, what slide am I on? Okay, sorry. So why do we stream? Well, the typical HDMI cable coming from my laptop, maybe 50 feet at most to get it to a projector. Well, that's good if we're within 50 feet. Then we have twisted pair cable, HDBaseT type stuff at each proprietary manufacturer. That's 100 meters. So a lot of times if we've got to go farther than 100 meters, we want to look about that. Well, you know, Extron and several manufacturers, we can also do fiber. We're looking anywhere from 2 to maybe 30 kilometers depending upon the type of fiber we have. What's the advantage to the IP? The IP is it can go anywhere where you've got a network. So not just am I spanning in this room, but I'm sending it out anywhere in the building, sending it across town, across the world. So that's where we have a lot of those advantages with going to IP on that. The reason we want to talk about doing the streaming is we're a very mobile society, and a lot of you as end users and a lot of you as designers, consultants, anything as such, your clients are international. They're worldwide. They're at least within the U.S., scattered around from city to city. It's hard to get everybody together into 4 physical walls and sit down and have a meeting. So it's things like that that are pushing us, and because we are more mobile, everybody's used to pulling up a YouTube on their phone, used to viewing it on a laptop. Why do I have to attend a meeting? So those are things to take into account when we're designing the streaming and the applications, what we want to go with that. So I promised a brief history, and this one I'm going to fumble a little bit with the slides, so I apologize on that. So where we want to go with this, I told you we've been doing streaming since mid-90s. So let's go all the way back to the MP3 stuff, the DirecTVs, the EchoStar Dish, anything that got away from those great big 6, 8, 10-foot analog satellite dishes. All of that was a form of compression. Anything with a form of compression is called streaming. We just weren't doing it over IP, we were doing it through the airwaves. Then we started looking about how do we do it over IP. Well, Microsoft and the real-time player, and we all know Microsoft was the big dog, 800-pound gorilla, and they won that battle. So they developed the software that allows you to stream and watch videos and play video clips onto your computer. Then we come into actual manufacturers that were developing hardware products that didn't have to have a computer, but they would set and they would stream those networks through. We get into then after that the H.264, we get into YouTubes, we get into Google. Everybody wanted to join in onto it. Why? Because everybody liked it. It was convenient. We can watch things now. And as we step through for the rest of this, I'm going to just talk about a few things. The VLC, if you've stopped by our booth, that's a very common, it's an open architecture device that allows you to view streaming onto your computer, of course. And then we have all of the new formats that are running through this as we run through the high-end units, VP9, 10, some proprietary other things. So it's kind of a summary is what we have. So the history going through this, we've been streaming since 1993. That's the basis of satellite. We had the MPEG-2 that I showed up here with, that's the premise of starting with MPEG-3 that went into the iPhone. Well, we all know how the streaming and the media storage onto any Apple device or any other MP3 player went through. So everything took off. It was convenience. And I think, especially on the audio side originally, because that's where people were sending it, the quality wasn't quite the same, but it was a convenience. You could put 1,000 songs onto a little 1-inch square piece. How cool is that, right? Walk around with headphones. So all of this stuff is what's allowed us to develop the streaming technology as we go through things. The primary thing we're all here for is streaming over IP networks. So when we talk about this, we have to know what's going on. There are several things to take into account when we talk about streaming over IP. We have bandwidth, we have quality, and we have latency. So you want the best quality, it's going to raise the bandwidth, and it's going to lower the latency. It's going to make it seem that it happens real time. So as we go through this little piece on here, and I'm going to turn around so I can actually look at it, you see how we're walking up here. So we've got 2 out of 3. You can't have low latency without increasing the bandwidth, and by increasing the bandwidth, you'd by default increase quality. If you want to lower the quality so you can lower the bandwidth so it doesn't take up as much of your network, you're going to increase the latency, the time that something actually happens across the board. So this is kind of just a little quick slide to help you understand how everything's going to start coming together when we start building a network. And as I talk later on in this, where I talk about things to consider on the network, this really is what it all gets back to. It's pick 2 out of 3, but you can't have them all. You can't have high bandwidth, you can't have high quality with low latency. Or I mean low bandwidth with high quality and low latency. So everything kind of runs through together. Live streaming versus on-demand streaming. And there's a little bit of definition on this, and I know most of us in here probably understand, but just to go through, live streaming right now, camera's on me, it's on the slides, and it's streaming it out over the internet, streaming it out to another room. It's happening right now. Now, as you're viewing it in those other rooms or wherever you might be viewing it at, you don't really know that what I'm saying right now happened 3 seconds ago when you're watching it. That's why setting in here, streaming me onto this screen is not the best use of a streaming application. I move my hands, and we demo this at our booth when you walk by. Something that moves right now, and you watching it live versus watching it on a stream piece is not a good application, and that's kind of annoying with people when you're watching it. So that's where that HDMI cable or that twisted pair cable or that fiber piece is actually best, where you have a line of sight to a live feed. You want to get outside of these 4 walls, and that's your best application to present that streaming. On demand, we all basically know where that is. You pull something off the internet or off some kind of site, and you view it when you need it. Talked a little bit ago about that corporate training or the new employee training that we have. That's an on-demand. Somebody's going to go to a server and pull that information off. So the on-demand streaming is something is stored somewhere and it's viewed when needed. So maybe that's downloaded and watched, pulled cache to the computer and actually played it back, or you're streaming it from that point, but it's stored onto a storage device. The on-demand, the latency is expected. The key is you watch the little wheel and it says it's downloading, and you're waiting on it. We all expect that. That's okay, but that's not really an acceptable thing in a live streaming presentation. So something that happened today in a live streaming and it gets stored somewhere else, those are the things that we want to kind of note about on that. Typically, examples of that are Netflix, also in the consumer market, video on demand from your cable or satellite company, those kind of things. Live streaming and recording for on-demand simultaneously. So this is an example of what this presentation today is actually doing. Not only am I presenting up here, cameras, the contents, everything are being streamed out other locations. And they're also being recorded for on-demand stuff. So as I slide through this, you've seen the little network cloud that's sending it out somewhere, right? So it's being stored onto a server somewhere for later viewing and playback on demand as needed. So they can redistribute this lecture today, assign it to anybody that wasn't able to be here. And the other advantage then that we have by having that storage server is when we send that stream out, it's designed to be looked at a certain type of device, a laptop or maybe a hardware decoder. But we've got this thing that we all talked about it earlier about iPhones or Android phones or tablets, whatever. They want to view video in a completely different mode. So that's an advantage of using with the storage server, the media servers. Those are going to do the conversion. So that's a device to keep in mind that you're going to have to take into account. Unless everybody is going to be viewing it on the exact same thing at the exact same time, now all at once, not only do I have to worry about am I unicasting or multicasting, but what's that interface going to be to do all those video conversions? Something as simple as recording. So what do we want to do when we record? We're going to save it and preserve it for future use. But how much storage do we need? So this little piece right here is just a reference point. And again, it's food for thought and things to take away. This information is also available on our website, but take that basic video cable. I talked about running my HDMI cable from my laptop or the Blu-ray or whatever. As you see on here, it's basically a 10 megahertz video signal. So take your 100 meg, your 1 gig video network, and you want to start dropping 10 megs of video chunks on it at a time. The IT guy is going to raise a flag or needs to be involved way early. So hopefully I'm giving you some information and some thought process to talk to those about. So what do we do with compression? we're going to convert that down, and we're going to, I said 10 meg. We're going to convert it from the 3.4 gig down to the 10 meg because the 3 gig's going to exceed your 1 gig network that you already have. So I can't drop a bunch of videos on there, obviously. So it's things like that that we take into account, we want to know. So in order to do the compression, the simplest thing to do, starting one, is to go from that color bit depth that I talked about, 12 bits, and getting technical, just how often is it sampled, down to 8. So we won't sample the color as far. Believe it or not, that's what your satellite box, your cable box, and your Blu-ray are already doing. Because that disc or that TV channel that's coming off, they've only got a certain amount of bandwidth they can do on that. Unlike the internet that is virtually infinite bandwidth, right? So they compress those things, and the easiest way to do that is don't sample the colors often because also those things are moving around. So that's the simplest, easiest, fastest way and the first step when you start doing compression. Compression is used in the broadcast realm every day. We have cameras, you have storage recording units, the pieces that Live is taken out into the film and filming things with. They're compressing those when they store those on the SD cards, when they store those on whatever. So we're all doing compression already. So this all relates to what we're doing to get this on the internet signal already. As I had talked about, we're all seeing compression every day. We just may not have realized it. And we've been watching compression for a very, very long time. So in recording management, this is everything that we're going to want to talk about in it. So we've got that content. We've got a camera image on me. And that's going to go into, this happens to show our box that we have in a booth. That's going to create the side-by-side windows. That's going to send this out over your facility network. And it's going to be viewed by, in this case, showing an education environment with student PCs. But now we need to get down to that media server. Why? That's where it's going to be stored at for long-term view, where somebody can come in. They missed my presentation today. They want to watch it tomorrow. The storage server is where those things are going to be. So in this whole entire thing, if you're going to be recording something, you have to have a storage management software of some type. And whether that storage management software is ours or it's something that you already have. And there are tons of storage management software and companies out there. But think about that as something that you have to have. Also, storage capacity. Yes, right slide. How much storage do you need? So whether your storage is going to be on-premise, in-house, or you're renting cloud somewhere, you got to pay for it. You got to buy a big server. It's got to have a big hard drive on it. Or you're going to go to a content storage company, and they're going to charge you based upon the gig. Well, how many gigs do you need? Again, this is a storage capacity calculator that's on Extron's website. And this is a shortcut for a formula that's about this big. And we won't go through everything that's on that. But what we basically would set up in this is you set up what's called the audio bit rate and the video bit rates. And I'll show what those are later. But that's how much compression are you doing and how much sampling are you doing. And you put in the duration of how much you want to do on this. And then you hit calculate. And it gives you this number, in this case of 2.34 gig. So take these settings right here for a 1-hour session. You've got a 1-hour meeting with average compression on this to do decent shrinking. That's 2.34 gig per hour. So let's just call it 2.5. You want to do this 8 hours a day. Now you're looking at 20. You want to do it 5 days a week. Start doing that math, how much storage you need just for a week. How long do you want to keep that video content? A month? 30 days, 60 days, 90 days? So this works both ways. A, it gives you a way to do quick math and intelligent conversation with that provider, and also make sure that that provider's not ripping you off by telling you need more, or he's not underselling you by telling you that you don't need as much as what you think you do. So this is just a formula to help you analyze when you're working with that content storage company, how much storage you actually need. Basically, the layout was streaming and recording. I talked about the little rubber band earlier, and we showed that. So it takes 2 out of 3. Same thing on the recording side. So when you do recording, what quality do you want it at? You want high quality? It's going to add the bandwidth. So these relate to it. And that means the storage capacity goes up. If you want to focus on minimal storage, then you're going to have to lower the quality, which is also going to lower the bandwidth of that video. So this kind of relates to the same thing, and it shows how the network bandwidth and bandwidth of media, quality of streaming, quality of recording, those are kind of that same rubber band. So you could interchange these things onto that piece that I showed earlier and accomplish the same thing. So bringing it all together, representation of a typical network, typical applications. You've got the great big giant network as it funnels through the pipe. Then you notice as it starts leaving your building, that's something that you got to consider. How much bandwidth does the wide area network or the remote sites that are going to be viewing it have? Kind of related to, we have the 10-pound bag, and we want to compress it down. Why do we need to compress it down? Because obviously it doesn't fit as we go through that. So that's what that whole compressor, and that's set up in the encoder. The compression, that's where everything's done at. So we have to take that 10 pounds, get it to 1 so it fits onto that local area network. Get it into something that's manageable, especially if it's leaving the network. Because as we see out here, we've got the 1 gig network, but we've got a 10 meg WAN going out because the bandwidth isn't paid for leaving the building. So, or maybe at the remote site, you paid to leave the building, but the guy that's working from home has a 10 meg internet connection, whatever the case may be. So all of those things have to be taken into account when you're putting the network together. Where are the people viewing it at? Where are they at when they're watching it? Streaming topologies. So this is where we want to talk about basic streaming. And I apologize for turning around and running the dual. I want to make sure that what I'm talking about is what's up there. So as we see this, this is a point-to-point stream, just like we're doing in the booth. I've got our encoder sending it over a network. We've got a decoder at the end. That decoder is putting the image onto the monitor. Very easy. Send it 1 point all the way around this building. The bandwidth is a little bit less as we go through that also. Break it out even bigger because I talked about I want to view it on a mobile device. I want to view it from a tablet. I want to view it on a phone. I want to view it from a computer. And not everybody's on my network. They're scattered out around the world. So in this analogy, this is where we have to come back into that media server. So we send that single stream, as you can see on here, to that media server. That media server basically is looking for authenticity from all these various devices. It knows you come in with an iPhone. It knows you come on with an Android. It knows you come in with a laptop. It knows you've got a hardware physical decoder out there. It senses all those devices, and it resends the stream out. So what does that do when that stream is rebroadcast? It adds a little bit more to that latency. So again, somebody's sitting in a hotel room watching me on an iPad right now, and it's being rebroadcast because it has to be changed to the type of stream that it has. We've maybe added another half a second or a second onto that. But again, because they're not watching me live right now, they don't know that when they see that 3 seconds from now that I actually moved my hand 3 seconds ago. Those are the things to take into account when you're laying out that network and talking about where you come from with it. In this application, we want to get into a content delivery network. So this would be a large scale deployment. And this is a little bit different than the media server because that single media server, everything's going to come into that. So that media server's got to have that bandwidth coming in, small, but it's got to have a huge bandwidth going out because you don't know how many people are going to be viewing it. Maybe in that other application, you've got 10 to 100. You can usually build a network okay for that. This is a very large deployment that a lot of corporations may use. So what do they've got? They come out to, this shows a Wowza server, it doesn't matter, it could be anybody's server. And then that's redistributed out into a content delivery network that basically, as you see on this is split into 3 more servers, handling different sets of bandwidth. So the server maybe for the East Coast is running all of these people. Midwest is here, you've got another one in LA for that, and you could take that further and send it all the way around the world. So this is that whole deployment, and I promised you bullets at the end to take away from. That's that whole deployment about what am I trying to do and where am I getting there and how many people are going to be seeing it. So when I talk about that later, these are the things to take into account. Not trying to overcomplicate the streaming, but there's a lot of streaming that gets deployed unsatisfactory or unsuccessfully because there's some steps that were missed along the way. And that's really the whole thing about what I'm going through with this today. There's a lot of things that need to be thought about when we go through it. On the encoder settings, so I want to focus on this with the highest amount of compression. So I've got this big video signal, I want to shrink it as small as it can. So what that's going to do is it's going to give me the least quality, but it's going to minimize how much bandwidth I need on the network. So in the encoders, there's a few key settings, and this just happens to show what our web page might look like inside of ours. But you want to look at your audio bit rate. If we're not playing music and all it is my voice talking, we can lower that audio bit rate, and maybe if there's no audio needed at all, you turn it off. It's one less thing that goes across that network. Same thing on the video bit rate. So in this analogy, there's no moving video other than me walking back and forth across the stage, but the content and myself are basically still, other than when I move it. So we can turn that bit rate down into a lower sampling. Another thing that's used a lot is what's called a variable bit rate. Now, this is a double-edged sword. And this is something that if you're not the IT manager, but you're wanting to work with this, you want to talk with the IT manager. Because a variable bit rate is just that. When there's nothing going on right now, the sampling and therefore the bandwidth drop. But now all at once something happened and I moved a lot or I put a real quick video up there, that spikes. Well, so the trade-off is not every IT guy wants to see those big, huge spikes. It's like the electrical surge on a power line. You know, you turn on all the lights in your house and then turn on the breaker and they all go dim for a split second. Your network's going to do that. But that's one thing that you can do to help minimize that network traffic. But you want to work with the IT team on that. You don't want to be surprised that they don't want to allow it, and you don't want to surprise them that you've set it up in a variable bit rate. And then as far as the type of H.264 and the decoding, there's different decoding platforms that they use. So a 4.1 is the newest. Maybe if everything you're doing are going out to mobile devices, you can lower that. And it just has to do with the sampling rate of what they have on those things. As far as on this slide, I'm going to focus on the image and sound. So again, remember the rubber band? If I want high quality, I'm going to increase the bandwidth. But I've lowered the latency. So we're going to do the same thing. We're going to jack up that audio bit rate because I want to make sure that whatever goes on, I hear it. We're going to increase the resolution. We're going to do the frames per second. So 30 frames per second is going to cover your motion video. Everybody's familiar with the high def 1080i stuff. All of that was 30 frames per second. So that's going to give you your motion video on that, and that's pretty well the best you're going to get out of H.264. On this, notice we're doing constant bit rate. So in order to achieve that highest quality video, we have to have reserved for us that constant bit rate. So you're going to say this is the sampling rate, which therefore your network traffic is always the same. But if you remember, I talked about previously, the IT manager may not like variable bit rate. So even in the other mode, you're going to allocate a constant bit rate, but you're going to be able to set it up what the bit rate is. So all of these things are what you want to work at that. And then there's other things that are called GOP and things like that. All that's going to have to do with is how fast the picture recovers if it misses a bit, how often it resends a full frame of video. The lower that number, and this sounds odd, the lower that number, the more often it's going to refresh and redo the video quality, which eats up more bandwidth, but the better your overall image quality is going to be. So those are kind of encoder settings that we talk about that we want to go through with that. Unicast versus multicast and what's called push-pull. I talked about unicast being one-to-one, if you will. Multicast, we're going out to tens, hundreds, thousands, millions. Push-pull, typically in a multicast, I'm pushing that stream out there and it's readily available for anybody who logs in. Pulling is, I only send it when something comes in and requests it. So in that analogy, on the simple unicast mode, which Our products support multiple unicast. They also support a multicast. But in a multi-unicast mode, the reason you would have to do that is because not every network supports multicast. You would have to talk with your IT engineers. There's what's called snooping, and we probably all know that even if you're not a network engineer, that anytime you say the word snooping on a network, it's going to raise eyebrows, raise flags. So there's some things that have to be set up, and most local area networks, no WAN support them. Most local area networks are not defaulted to support multicast. So in this application, we want to do 3 unicast streams because we just simply can't do multicast for whatever reason. The issue we have to know on this is I had that bandwidth of this one unit. I'm going to, each time I send that now, I've tripled the amount of bandwidth that I need on that pipe. So therefore, taking that into consideration, you may have to go back and change some of those other settings to go to a lower quality if you're eating up all of the network. In a multicast environment, the biggest advantage to that is I send the stream once and I just use that set of that bandwidth up. That's all that I use. Everything else is managed and routed through the switches. The switches snoop to know if that computer or that decoder are authorized or if they request that. So instead of sending that signal out 3 individual times and eating it up 3 times, I send it out once and then the hardware handles the rest. But again, emphasizing it takes special switches, more importantly, a special setup and configuration in those switches. And none of us in here can guess. That's why we have to go with the IT managers. We have to respect their territory. We have to respect their wishes, whether we agree with it or not. And sometimes they're going to say, yeah, if that's what you want to need. The last thing a corporation wants to do, and the reason they protect that is we all rely on our email, especially now that we're so mobile. We rely on the email servers and we rely on our phones. And 85, 90% of the phone systems out there are VoIP. What is that on the network? So all at once you drop on 3 10 meg video clips. That's why some corporations even don't allow you to go watch YouTube on the network. All at once the network is flooded and you miss that important phone call. Your email servers crash. You can't conduct day-to-day business. Most companies, the day-to-day business is more important than us being able to stream a video across it. Streaming design considerations. This next one is the thing that I promised, that if anybody wants to take notes, these are the things that you want to take notes about. And as I look at this, the first thing, yes, design considerations. What am I going to be streaming? You're going to be streaming basically motionless video, PowerPoint stuff. Am I doing somebody dancing, moving, walking around the screen? We talked about graduation earlier was one of the types of things that is an application. A lot of times those are getting streamed anymore. That has some motion to it, but there's a lot of still time in that. So those are the types of things we want to analyze. Where is it going? I talked about where is it going. Is it going from this room to a room at the other side of campus, across a commercial facility? Is it just going on the other side of the wall? Or is it going out to the world? How is it getting there? Is it going to be on your network? Are you renting the network out there somewhere? Are you going through that, network management company, the content development as far as the storage things, anything like that? What is it going to be displayed on? We kind of touched on that as I went through those slides. So is it going to be everything displayed on a projector? That's real easy. You put a hardware decoder on the back of it and there it is. But no, a lot of times the purpose of streaming is because we all can't get in the room. Somebody's going to view it on their laptop. Somebody wants to view it on their phone or their tablet, in addition to the 500-inch projection screen. So those are the things. What is it going to be displayed upon? How many? Because I showed that medium and large deployment. So you need to know how many, because again, how big is your network? How much traffic is it going to be able to handle in a multicast application? Or do you need to go to a deployment where everything is off-premise? And that's working with your IT guy. But this gets overlooked a lot of times, and this is why streaming gets a bad rap, because it crashes the network sometimes. Are you recording or recording capture, storing it, whatever the case may be. So something to take into account. If so, are you going to stream it or are you just going to record it? You're going to record it and stream it. So this is where some of our product comes in real handy. I can record and stream at the same time, or I can record only or stream only simply by sending it a control command or checking it off. There's product out there that only streams, but you want to record it. So now you got to buy another product that does that recording. So keep that cost in mind also. And now you've got to take that IP stream. How is it going to go into that recorder? Is it going to feed the recorder, or does this camera have to be split and go 2 different locations? So those are the things that you need to take into account about, is it going to be recorded also? How robust is the network? So this kind of ties into all the rest of these. Everything else on here gets into how robust is the network. That's the bottom line. So just as I showed that storage calculator earlier, you could reverse that into a streaming bandwidth, and we have a direct streaming bandwidth calculator on our website. Again, it takes a formula this big and brings it down to a few clicks. We've all worked and been on the network, and I've been around in the industry for many, many, many years. And a lot of times we say, well, bandwidth isn't an issue. Bandwidth isn't an issue until we all start doing the math and figuring out how much bandwidth we really need, and then all at once bandwidth becomes an issue. So this is a recap of the slide, and I skipped over one on that, and that's okay. So this is summarizing all of those things that we've just been talked about how everything comes together on that. This is a sample that I talked about the video sampling earlier, the 12 bits. So as I view all the way to the left, that shows all the color being sampled all the way down to what it does on the right. So that's a way that we use to shrink the amount. In addition to all those compressor settings or the encoder settings to do the compression, this is the easiest way to remove those things. Compression logarithms. So there are basically 2 types. There's a standard called H.264, and then there's a proprietary. Okay, in this case, I'm talking about Extron, and we have what's called a Pure 3 in addition to our H.264. So that's something to take into account, is H.264 has limitations in itself. Maybe it won't give you the quality that you need, and that end result would be a proprietary compression. Our Pure 3, as an example, that's a proprietary, and it has applications that the government likes because it's also secure, it's not open platform, it can't be hacked as well. There are other manufacturers that have their own proprietary things, so take those under consideration. The problem with the proprietary version, you can't view it on your computer easily. You cannot view it on any tablet or any other mobile device. So if you have to do that, then that becomes part of your topology. Basically, you're building 2 completely different networks. I talked about needing to know the bandwidth. Everybody, I'm going to assume in the room, has internet at their house. And there's tons and tons of apps and websites that you can go to that gives you your speed. Speed is only part of the story. All of your IT engineers and managers are going to have this type of software that gives them basically what's called throughput. It's going to be bandwidth. It's not just speed. Speed is only one thing. The throughput affects packet loss, and it's your network jitter. That's what makes your video image drop in and out. It's very rarely the bandwidth, as we call it, it's very rarely the speed. It's all the bandwidth as it relates to all these other things. So does that computer back there have audio? Will it play this clip? Okay. Anybody that watches the Super Bowl or watch sporting events, this is sorry. If you click that in the middle of that, I forgot I don't have control of that. The mouse and click, there's a play bar hidden in it. If not, I'll go through real quick. So that's okay. So basically the bandwidth, if you remember the Verizon commercial, and I'll go back, I know it started in the Super Bowl and it's been played many, many times. So they talk about, it's a door and you've got 100 people and that door is able to pass everybody through. Now all at once, everybody wants to leave the room at the same time. What does Verizon claim that they do? And I'm just using this as an analogy. They make that door bigger. Oh, the door, and it's open and it's getting bigger. Now all at once it handles all that people. That's the same thing of what we have to take into account when we do the network, because that's your bandwidth. It has nothing to do with the speed of how fast the people get through the door. It has to do with the efficiency of how they get through the door. Can I only send one person through the door at a time, or can I send 101 people or 1,000,001 people through the door? That's the same thing with the video clip, the video file. Can I only support one without killing the rest of my network? So criteria 3 that we take into account on this is latency. So there's a few things that have to have low latency. Low latency means it better be almost instantaneous from the time that I see it to the time that it happened. Robotic surgery. Obviously, as the doctors are controlling the robotic devices, or you're doing anything like that, it has to be essentially live. Less than 50 milliseconds, that's instantaneous. Device controlling, you're turning something on and off from a remote location. Door has to open and close immediately, whatever the case may be, for security reasons. That's less than 100 milliseconds, a tenth of a second, that's instantaneous. Video conferencing is another form of streaming. Whether we're using Skype or whether we're using a Cisco, and I'll say them because they have a booth out here, a Cisco codec to a Cisco codec, we're talking face-to-face. In that application, that's a two-way communication. We're supposed to accomplish the same thing as us sitting in two chairs facing each other. In order to do that, that has to be low latency. That's your 200 milliseconds. That's a fifth of a second. So those things take into account. Surveillance cameras, maybe traffic cameras, surveilling outside of a building. You have to know instantaneously when it happens. Things that accept high latency, meaning it could happen, in this case, up to a second, just general monitoring of something. You want to know every few seconds what happened outside of a door. Webcasting, kind of sort of streaming. I'm just sending it out over the web. The low video bitrate resolution, so basically as we lower that sampling down, it's going to add that 5 to 10 seconds. Is that acceptable? You have to know that. It's your project. Sometimes it's going to be acceptable, sometimes it's not. Video on demand, you're pulling that down from that piece, 10 to 20 seconds. It might take it 10 to 20 seconds for that to load and go through. That's considered acceptable in most applications. Now, if it's really, really huge with a really, really slow network at peak hours, we all know that takes a long time. We talked about management software. So whether it's our software or somebody else's, you got to have something that manages and schedules those streams possibly. You got to have something that manages the content being paid out, the ingest of the content, everything going through it. Sample streaming system designs. So these are just some sample types of rooms that you have. So stop by our booth. We have a streaming resource guide that you could take with you, obviously. But some types of applications, lecture capture, nothing more than a camera and a content, things going into this, being streamed out and or recorded. Education, corporate stuff. We talked about standing up here rehearsing, doing peer review. Maybe a new teacher, a new presenter, they want practice, and everybody sits back and reviews what they're going on with that. Very common, IPTV system. So take a few, I'll say TV boxes, whether they're cable, satellite, whatever, it doesn't matter. Assign those fixed channels. Why? Then you can send them over a network and be viewed on TV scattered throughout the building without running that TV cable. Maybe out to computer desktops. A lot of times in call centers, okay? Maybe it's a phone company or an electric company monitoring the network. They got one of the TV channels that's nothing but the weather channel. It views what's coming on locally from their favorite local, whatever TV station that it might have. Those are types and things of samples with the distribution on that. That's the overview of everything that I wanted to talk about. I apologize for a little bit of the inconvenience and me fumbling around with the slides going forward, kind of running a couple different computers here. But anything that I mentioned that you want some clarity on or talk about, or things that I didn't mention that you've heard buzzwords about, I'll do my best to try and answer those as we go through with that. But that is the core of my presentation I need to be able to present to you today. Goal is you walk out of here with a few buzzwords and a few thoughts that need to be considered when you do that streaming deployment. Obviously, if you stop by our booth, be happy to show you our streaming product live, but easier to do it here than sending it out to 550 sites at the same time. Yes, sir. So you're doing the live stream from this room out to the world somewhere that I don't know where they are. Okay, so the first thing that you're going to want to have is basically a media server out in the cloud. And I use that term, it just isn't in this room. So I'm going to typically set that up for that server to pull my unicast stream. So I send that stream to that media server, and then from that point, it's going to be the traffic cop with the login authentication, and it's going to do the conversions of the type of stream that that device senses it from. So you may have login credentials, and you log into that from your laptop, but now you're going to go mobile, and you log onto it with your phone. That device is going to sense the IP address and what type of device you have, and it's going to redo that stream and send that one to you. So typically that would become a multicast at that point, again, to minimize the network, and that's going to do the conversion, and it's pushing those streams out there, and in essence, those streams are out there ready, just waiting for people to log into it. So in the simplest mode, you need an encoder, and then you need to know what are they going to view it on. If they're going to view it only from mobile devices or laptops, then you need the encoder, you need the media server, and then everybody brings their device. If you want to view it, in this case, like on a projector, maybe you would have to add a decoder at that projector so it could be presented to this room. And that's real common in commercial facilities, do what they call town halls, where I would stand up here maybe as the CEO of the company, and it's a state of the company address. So it's live in here over cables, but now the camera and everything is sending it out, and it's streaming it to across the United States to another room just like this, where everybody's gathered and watching it. They would put a decoder at the projector. Good question, thanks. Yes, sir. Uh-huh.
So what do I have to do? Take the worst case scenario and plan for that?
Sort of. So what you would also start out with is by eliminating what you don't want them to view it on. So let's say you don't want them to go to a YouTube channel or to some other Google channel of some type. You want to eliminate that. So therefore we've taken that out of consideration. So you being the church, you also probably are not going to have the big giant media server in your facility. So that's where you're going to rent that space from a server management company. And then there'd be a couple ways to do that. You tell them, I want to stream it in, quote, 1080p or 720p. What resolution are you going to want to do it at? You can set that. And therefore, by that, if you only stream, let's say you've got one service or 3 services on Sunday, that's part of what you would figure out what you want to do. And if you only want to use it on Sunday, then you're not paying for it the other 6 days out of the week. So you find that management provider, or the media server provider that will rent you the one day. And there's tons of those. I mean, that's a very, very common in churches. And I know there are churches even that share the same thing. So like if you're a Catholic church, they go together and do this. Another common thing is maybe you don't want to stream it live, but you want to record it. And so then I'll say after service today, and I'm from a small town, and this is how my church does it. They record it, and then when everybody goes home at lunch, of course, they eat the lunch, and then the first thing they do is they upload it onto their website. Because with our system, and most, but MPEG-4 is a very, very common protocol to do the video recording in, because then it can be fully viewed on almost anything. So you take a thumb drive, you take it to your laptop at home, you upload it to the church's website, and you leave it up there for an entire week. So maybe that's something to consider, because I had talked about, does it need to be recorded? The advantage to streaming it now is we're home in our living room, or we're home in bed, we're wherever we can't get to the church. I'm watching it virtually live, maybe a few second delay. But if I'm sick, you still want to enable me to watch that service by being able to record that and post it somewhere. So that gets back to asking those questions. Do you want to be able to record it also? And I know sometimes churches do where they're in a smaller area and network is hard to come by. And if you're in a smaller church, the network people and the audio guys and the video guys are volunteers. Sometimes they don't have the ability to even get the network set up on a regular basis. So I'm only given that as to your direct question answer was you would still need that offsite media server, and then it would pull those things in. But an additional thing to do is to possibly record it and then post that recording, and now you have it up there for a week for somebody to watch. Thanks. Any other questions? Great application questions there. I appreciate it. I mean, that's if there's no other questions, that's really all that I have. I thank you very, very much for, yes, sir.